All right, here we're looking at section 9.6. Our learning targets for today are to interpret and use frequency. Then we're going to be writing some trig functions, and then we're going to use technology to find some trig functions. So the first thing we want to figure out is what is frequency. We've talked about periods of our sine and cosine functions, mostly. We can talk about all of our trig functions. But the fact that they have periods, that we do the same thing over and over, we use these for oscillating motions. Oscillating motions are things that repeat in real life. So we're going to look at some sound waves, pendulums, seasons of the year that kind of follow the same pattern. We're going to be looking at the frequency here. So the frequency is the reciprocal of the period. So once we're going to be finding the period, then we use the reciprocal, which is going to be 1 over the period that we found. So the frequency gives the number of cycles per unit of time. So the period, remember, is the length that it takes to get through one cycle. Frequency tells me how many cycles per unit of time. That's just our big difference there. So here we go. We're looking at a sound wave. So a sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions. That produces a pure tone with a frequency, which is f of 2000 hertz, which is in cycles per second. The maximum pressure produced from the pure tone is 2 millipascals. Write and graph a sine model that gives the pressure P as a function of the time t in seconds. So here's the information that I'm given so I can see kind of the sound waves. It is following that kind of oscillating that sinusoidal graph. Okay, so first I have to find my values of a and b. So I want to use P equals a times the sine of bt. And we're using t, right, because we were told we're looking in time. So the maximum pressure is 2. So A was 2. And then I can use my frequency to find B. So I know that frequency is the inverse or the reciprocal of the period. So I'm just going to go and rewrite this relationship. So I was told that I have the frequency. And since we're looking at a sine curve, I know that my period is 2 pi. So I substitute in what I know, and then I multiply both sides by 2 pi. And so I end up with 4,000 pi. So P, as a function of time, is given as this P equals 2 sine 4,000 pi t. So now I can graph this, right? So my amplitude is always my A value, which here is 2. And then my period is 1 divided by the frequency. So 1 over 2,000. So then I have to find some key points, right? Where exactly am I graphing? And then I can find my maximums and minimums and then graph my equation. Okay, so looking through this, when we're looking at these real life models, the easiest way to really graph these is to use our Desmos or use our graphing calculator. Just know the major points that we want to find. We always want to find the intercepts, right, where my x is 0, and then I find the maximum and minimums, which are right in between those intercepts. Okay, so here's my graph of this 2 times sine of 4,000 pi t. So think about this. What has changed here? So now we're going to be writing our trig functions. Okay, sine and cosine functions are called sinusoids. So that's just the kind of graph that they make. Since they both are that curve that goes up and down and up and down, it's called a sinusoid. So one method is to find my values of a, b, h, and k, right? So here's my kind of parent functions, my a sine b times the quantity x minus h plus k, or I can use cosine. So my absolute value of a is the amplitude, 2 pi divided by b is the period, h again is always my horizontal shift or translation, right, back and forth, and k is my vertical shift or translation up and down. So I can use this information to help me write these trig functions. So now here I'm given a function with some data points that are labeled, and I'm asked to write the function. So first I want to find the maximum and minimum, which I'm shown here on the graph at pi over 8, comma 5, and 3 pi over 8, negative 1. So from this graph I see the maximum is 5 and the minimum is negative 1. So that tells me, that can help me find the vertical shift, right? How much I've shifted the whole thing up. So the vertical shift is the middle of these two numbers, or the mean. So I take the maximum plus the minimum and divide it by 2. So 5 plus a negative 1 divided by 2 gives me 2. So my k value is 2. So now I have to figure out, do I want to use sine or cosine for this one? So I see that because my graph crosses y equals 2, it going up through that point, right, on the y-axis, I'm going to use sine because I have no horizontal shift then. So it'll just make it easier. I could still use cosine, but if I use cosine, then I know I'm also going to have a horizontal shift, which makes things a little bit more difficult. So I'm going to go ahead and use sine here. So now I want to find the amplitude and the period. So to find the amplitude, here we're looking at period first, so I take pi over 2 equals 2 pi over b, which gives me that b equals 4. Right? So that's how we found the period. And I can always find the period by saying, well, how far did it take me to get from here, this top part, to this top part? Well, I know I went 2 pi over 8 to get down here, so I know I'm going to go 2 pi over 8 over here, which gives me my answer there. So now let's look at the amplitude. So the amplitude, I take my maximum minus my minimum divided by 2. So my amplitude is 3. And I can see that on the graph as well. So if I know my midline is 2, which I found was my vertical shift, I can see 1, 2, 3 is my amplitude for this one. So now I have all of the pieces, so I can write my graph. So my amplitude was 3. I did not have a horizontal shift, so I don't need anything in with my x. So my b value was 4 and my k was 2. So then I can take this equation that I've come up with and check it by graphing it to make sure that I get the same graph that I started with. So here's another kind of situation where we can model with trig functions. So two people swing jump ropes as shown in the diagram. The highest point of the middle of each rope is 75 inches above the ground, and the lowest point is 3 inches. The rope makes 2 revolutions per second. Write a model for the height in inches of a rope as a function of time, given that the rope is at its lowest point when t equals 0. Okay, so we have all the information we need. So I see here that my rope oscillates between 3 inches and 75 inches above the ground. So I want to go ahead and use sine or cosine because it's going to go up to 75 and back down to 3, and then up to 75 and back down to 3 and up. So I know I can use sine or cosine. Okay, so first I find my maximum and minimum, which is at 75 and 3. So then I can figure out my vertical shift, which again, I take my maximum plus my minimum and divide it by 2. So my k value for this one is 39. So now I have to figure out, am I going to look at sine or cosine? So I want to figure out when t equals 0, the height is at its minimum, right? It's not on the way up, it's not at the top, but it's at the very bottom. So I'm going to go ahead and use a cosine function that's been reflected, because our parent cosine function, right, crosses its maximum at the y-axis. Here we're going to cross at our minimum, so I just need to have a reflection. But this also allows me to have no horizontal shift, so my h is still going to be 0 here. So I want to find the amplitude and the period. So the amplitude, of course, is my maximum minus my minimum divided by 2, which gives me 36. And then I know that that a is going to be negative because I decided to reflect it over the x-axis since I modeled that. So now I can find my period, okay? So because the rope is rotating at 2 revolutions per second, 1 revolution is in 0.5 seconds. So my period is 2 pi over b equals 0.5, right? Because I'm knowing it's per second here. So then I can solve for b and I get b equals 4 pi. So now I have the pieces I need, so I can rewrite my equation. Okay, so I've got a negative 36 cosine 4 pi t plus 39. I go ahead and I can graph it and look at it, and I can also use my table to check out the model. So if I put in 0 seconds, it's at 3, right? And if I put in 1 second, we're back at 3, but I've done 2 revolutions, and I'm told I do 2 revolutions per second. So if I follow along my table, I know I was right in my equation. So I want you to try these, especially looking at how can you get from this graph, what information do you need, what information do you have to find, and then how can you use that to write your function. So now we're looking at this table. So a table shows the numbers of hours of daylight in Denver, Colorado on the 15th day of each month, where t equals 1 represents January. So write a model that gives n as a function of t and interpret the period of its graph. Okay, and this is where we're going to use our sine and cosine functions a lot. This is the most often used real-world situation where we look at this. So we can kind of check daylight. We also look at temperature this way a lot of times. So the first thing I do is I'm going to use my technology, and I can use Desmos as well. This example just walks through using a TI calculator. So I enter my data in my calculator or in my table in Desmos, right? Just all of my data pieces. So then I make my scatter plot. Then the next thing I do is I see that this does look sinusoidal, right? It does look like it has that kind of curve to it. So I'm going to use a sinusoidal regression. I can do this in Desmos as well. So just remember, when we're doing a regression in Desmos, it's going to be, I'm going to have y sub 1, because this tells me which table, and then I have to use the little squiggly, and then I can just write the same thing as I have here. Be x sub 1 plus c plus d. And if I write this in the line below in Desmos, I will get the same thing that I'm doing right here. Okay, so now I put in my information here. You may get different numbers for C occasionally, right? Because remember, C is just a horizontal shift, and I can shift it to the left a little bit, or I can shift it to the right quite a bit, and I will get the same thing. So there is a possibility of some different C values that we can talk about how to get different ones. So now I can graph the data in the model in the same window and see that, yep, I'm pretty darn close. So this model actually fits pretty well for my data. So I'm going to go ahead and write out my equation, which is 2.76 sine of 0.51t minus 1.59 plus 12.1. So the period, which is 2 pi divided by this b value, right, which was 0.511, is approximately 12. This makes sense for us because we're looking at a period since there's 12 months in a year, and I would expect the period to the pattern to continue year after year, right, pretty similarly. So the period here makes sense once we found it again from our equation that we wrote. So now here is a very similar one to what we just did. To go ahead and try, see if you can use Desmos this time to help you find the equation for this that models this data. So now we're going to look at our learning targets again. First we looked at and used frequency and what frequency means. Then we looked at writing trig functions. And then our third one, which we're going to do most often, we used some technology to find those trig functions. We have to input our data, and then we can use our regression features to help us write the equations. Now that we've worked through all of these learning targets, go ahead and work on your homework for 9.6.